Here we have an application of a logarithmic equation. It's the Richter scale. The Richter scale, if you think of earthquakes, uses this formula. A is the amplitude in microns. B is the vertical motion, or T is the vertical motion, in the periodic side of that periodic wave in seconds, and B is the factor that accounts for the weakening seismic waves. So I want to find the intensity of an earthquake with an amplitude of 250, so that means A is 250, a period of 2.1, so that's T is 2.1, and B equals 5.4. So we just plug it in. So R equals the log of 250 divided by 2.1 plus 5.4. So we're just going to use our calculator here at this point. So I'm going to say the log of 250 function log of 250, need a parentheses there. Oops, got an extra set of parentheses. 250 divided by 4, divided by 2.1 plus 5.4. Let's make sure I put the right numbers in. Yep, I did. So this Richter scale would be 7.48. Let's take a look at example 21. It says the city is not concerned about earthquakes with an intensity less than 3.5. An earthquake occurs with an amplitude of 125 microns and a period of 0.33 seconds, and B equals 1.2. What's the intensity of the earthquake? Should the city be concerned? Okay, pretty much the same thing, isn't it? So I'm going to take the log of 125 divided by 0.33 plus 1.2. So we said the log of 125 divided by 0.33. Plus 1.2. So we get a Richter scale of 3.78. Yes, they should be concerned. An earthquake with an intensity of 6.1 or greater can cause considerable damage to those living within 100 kilometers of the earthquake center. Determine the amplitude of an earthquake whose intensity is 6.1 with a period of 3.5 and B of 3.7. Okay, so in other words, this time we're going to have to work backwards. We know the intensity is 6.1. What I don't know is I don't know the amplitude. So I'm going to say the log of A over, in this case, period of 3.5 and a period of 3.7. So let's solve for A. So the first thing I'm going to do is I'm going to subtract 3.7 from both sides. See, 11 minus 7 is 4. 5 minus 3 is 2. So you get 2.4 equals the log of A over 3.5. So get rid of the log. I'm going to take it to the power of 10 because it has a base of 10. So 10 to the 2.4 power equals A over 3.5. So my exact answer is 3.5 times 10 to the 2.4 power. Let's go ahead and do that. So 3.5 times 10 to the 2.4 power. Let's see if I did that right. Yep. So my amplitude would be 8791.6. So anything with that bigger amplitude is going to cause major damage.